In late 2024, after 20 years of innovation, we at NetBrain proudly released our newest version of our next-gen platform, which combines AI and automation to solve the toughest network challenges and accelerate your business outcomes. One of the main outcomes modern enterprises are looking for is to gain visibility of their hybrid network and understand if devices are drifting from their ideal configurations. We call it Golden Configuration Validation. We can also set up automation to help validate network states. Today, I want to showcase Release 12's Golden Engineering Studio and how it enables organizations to reverse engineer rules and state to learn and grow. NetBrain discovers two dimensions of the network configuration and network state. Network configuration refers to the rules and guidelines you set for your network design. For example, all devices in America use 10.1.30.1 as the NTP server. You can create Golden configuration templates based on these rules using reverse engineering. Reverse engineering enables you to navigate through years of network configurations and determine which configurations should be used as the Golden template. We can then use these Golden templates to create Golden configuration rules, which will help ensure network configurations are not drifting from their intended designs. Network state refers to the behavior of your network devices and protocols. An example of this could be checking HSRP state changes and ensuring ACL consistency across those failover devices. To achieve this, NetBrain allows you to define Golden features based on the specific technologies operating in your network, such as BGP, HSRP, or multicast. Golden intents can be built for these features to verify elements such as configurations, neighbor relationships, and failover states remaining unchanged. Golden intents are no code and created within an intuitive canvas. I will be taking you through two different demos in this video. The first demo will show you how it can build an NTP Golden configuration rule in the all-new Golden Engineering Studio. The second demo will show how easily we can build a Golden intent to validate HSRP states and ACLs. So let's jump right into the first demo. For my desktop here, let's go ahead and open the Golden Engineering Studio. Now, the Golden Engineering Studio is going to be a one-stop shop for anything Golden intent or Golden config related. Let's go ahead to the Golden config discovery tab. We'll navigate to our system folder and create a new rule. So here in the this rule section, we'll give our rule a unique name. In this case, NTP config rule. And we go ahead to the config parser page where we'll tell NetBrain how to pull the config from the devices. In this case, we'll select an NTP config parser that I've already built. We'll add this as the target config for the Golden rule. And we'll save and we'll move to the Discover tab, where in the Reverse Engineering tab, we can utilize reverse engineering on all of our network devices to tell us how many variations of NTP configuration we see on our network. And just a couple seconds here, we have a result telling us that there are 7 total variations. Now I can dive in here on the number of devices and see the first variation is for America devices, and we'll close that. The second variation, which we'll look at here, with DE and UK looks to be for EMEA. You can see that here. The third variation is going to have Japan and Singapore, which is APAC or Asia. The other ones look to be invalid one-off configurations. So let's go ahead and select the first 2 variations we looked at, as those are what we expect and want to use for the template. We'll add these to what's called config parameter, which allows us to add dynamic criteria to these templates to be able to use the appropriate template at the appropriate time. And you'll see what I mean here in a moment. So we save this parameter, and here we can use the criteria like I mentioned. So we're going to use region, right? So that means for this particular NTP, region needs to match America. And we'll do region matches EMEA, and then region matches Asia Pacific or APAC. So this now ties each template to a specific region that our devices reside. So we use the appropriate template at the appropriate time or for the appropriate device. Now that we have that complete, we've jumped back to our rule. We'll go to the forward engineering tab and we'll add a representative device. This is a device that represents all devices that this rule would be on, but we're using it as a sample. So we're going to retrieve the NTP config from this device. And then now that we have it, we'll go to the define and test section and we'll update the golden config template to use our parameter. And that's just in the tool dropdown here. We'll go ahead and find our parameter and add it to the template section. We'll backspace out the rest of the config because we no longer need it. We'll go ahead and add a scope of devices, which will be our Cisco iOS routers and switches. We can leave the alerts as is, but we do have the ability to change them. And let's go ahead and run the test. This will test the rule on the devices we selected to make sure that it works, right? And here we can see we're actually getting messages. It complies with the golden, and there are 2 alerts. So we know it is working and actually telling us that there are problems. So let's go back here and add this as our golden, which you can see here, it goes to the bottom of the screen. We'll go to the alert tab and run this verification live as it is now a completed rule. Once this verification is complete, as we can see here with the greens, and again, we're finding 2 alerts, which matches our test, we can go to the map. On the map, we'll go to the intent tab, and in the golden config section, which is already highlighted, we can find our new created rule. You may have to refresh, but we'll scroll down here and we'll look for our created rule. I'll just keep going here and we can see there it is, NTP config rule. So now we can expand that rule and actually see the details of the validation. And if there was problems, they'd be highlighted in red. We can even see for each device the problem. So I could select a different device like I did here in EMEA, but I can see that we're actually finding a problem. So we can see those 2 lines are missing. Pretty cool, don't you think? Let's go ahead and move on to demo number 2, where we're going to be building a golden intent. We're back in the Golden Engineering Studio. So let's go ahead and go to the golden intent section. We'll build the new intent in the HSRP folder, and we'll add the new golden intent and give it the name HSRP_webinar. Once we save, we'll see the canvas. Let's go to the feature and add a feature to begin. Here we'll use the HSRP feature that I've already created for all our HSRP devices, and we'll only select all devices and low priority. In the all devices, let's go ahead and add a parser to pull some data from that device group that then we can use for diagnosis. Here, we'll look for a parser for show standby. And the good thing about NetBrain is we have a lot of these pre-built. We can also use ones that you've built, so you don't need to keep repeating work effort. So here, we'll select that show standby parser. It looks good. And once we have that parser, we can then add a diagnosis using the variables from that parser. Here, it's going to be a diagnosis against the baseline, and we'll give it a name of HSRP state checks. And then within that diagnosis node, you can see on the bottom, we have some options. So what I'm going to do, and this compared to the baseline, is I'm going to focus on only the state, as I want to make sure and verify if the state's changing. I'm able to update these alert messages. There's also a kind of default one that appears. In this case, I'm updating it to HSRP state changed. So something simple, and I'll actually even add some variables here to show group ID and virtual IP to get even more specific. So I can pull those variables that I found within the parser. I can also get the green message, but in this case, I'm going to go ahead and select it if false, which is a green message, and we'll go ahead and update that as well to say no HSRP state change. I'll just do some correcting here and get that text in here. So now with those messages, that diagnosis is complete. So we'll go ahead and hit save. Now I can focus on the next section, which is for the ACL inconsistency. First thing I want to do is add the high priorities, but as a neighbor. So here we can add a neighbor device using a golden neighbor, and I'll use HSRP to find those. I can then filter the neighbor devices using some criteria. In this case, the virtual IP and the group ID for HSRP. And this helps me create a relationship between those high priority and low priority devices as it pertains to HSRP. I can do it very quickly with dropdowns and no code, like you can see. So that new neighbor device appears. I'm just going to rename it here to high priority devices. We save again. We'll go ahead and add parts of this one. In this case, we'll use configuration, and we're looking for ACL configuration. Now, NetBrain has a good job of having parsers for configurates, but again, we could use our own as well. Now, I'm not only going to do it for high priority, I'm also going to do it for the low priority devices as well. So I'm going to repeat the same process. We'll get that ACL configurate. There we go. So I'll just drag this into place for it to look nice. You can see how simple I can add nodes and do this here, and it builds a nice graphical representation. But here we'll go into another diagnosis, and we'll call this one ACL consistency check. In this case, instead of baseline, I'm going to compare it to another variable, and I'll set that other variable here in a moment. What I'm going to do here first is change that to ACL config instead of extended ACL. That'll make the logic make more sense, and our ACLs are standard instead of extended. So now I need to compare this to another variable. I'm going to pick the same variable, but from the low priority devices, and you can see it appear there. Now, for the logic, instead of just equals, I'm going to do a match pattern. This way I get more granular in the matching, and I can use the variables from the match pattern rule in my messages if I wanted to. In this case, for simplicity in our video, I'm just going to write a very simple message that says ACLs are inconsistent. And for the green message, I will do the same, but saying ACLs are consistent. So this is a simple message. Of course, we can add more details if we want. But here, I just want something simple to complete the diagnosis. We'll go ahead and save again, and now we're ready to build it. So this will replicate our created golden intent to all the devices that are part of that feature. So we'll go ahead, we press build, we'll press yes here, and we'll let the build process begin. We can see the build process is finished, and great, we have 18 intents created, no errors, no warnings. Perfect. So let's go ahead and publish this for use across our network. We can use on a map or schedule it after this is done. So we'll click publish. We'll quickly click yes on these messages. It's just saying there's been updates, but we're okay with that. And we'll go ahead with the publishing process here. So let's go ahead and wait for this publish to complete, and we'll show you what the output looks like. So here the publish is complete. You can see 18 member intents, 100% coverage, and the publish time as well. So let's go ahead to a map and see what this looks like. So here we go on the map to the golden intent section in the intent pane, and I'll refresh it to make sure my intent is there. And I'll just search for the keyword webinar because that was the naming I used. And we can see here the golden intents appearing from my search and not executed, which is exactly what I expect as I just built it. So if we click golden check, we can see a graphical representation of the golden intent being executed on each device, whether it's the state check or both the state check and the ACL consistency check that we see on that one switch. We'll go ahead and execute it, and we'll see the graphic update, which is really nice, and really shows us this happening in action. And we can see here we have some reds and greens, so we are finding some problems, but we're also finding a lot of successes as well. So let's go back to the map to more easily understand the output. So we can see on those Japan devices, there is an ACL problem. ACLs are inconsistent, and also there's no state change. All right, so throughout this map, for example, to the LA devices, and see greens as well. And over here on the London devices, I'm also having an ACL problem. Now we've learned how to protect the network against configuration drift using golden configuration rules. We also saw how golden intents can help to validate the state of the network. But that's just the beginning. Learn more about all of the benefits of Golden Engineering Studio at our webinar every Wednesday, where we go deeper into these innovative new features. Are you ready to experience NetBrain yourself with a full hands-on interactive test environment? We're offering a 90-minute instructor-led sessions where you get to experience the power of AI and automation in action to increase troubleshooting efficiency and proactively protect against future issues. Whether you just want to learn more or want to get hands-on in one of our experience labs, we invite you to go to any of the links in the description and join us at netbrain.com.